Hello everybody, welcome to day 2 of solving polynomial equations, section 5.5. Mrs. Connors, in the previous lesson, reviewed factoring polynomials of different forms, and what we're going to do today is apply those skills within the context of solving equations. So before we jump into it, there's a few things I want to remind you of, and also introduce the fact that what we're going to be using in order to solve these equations is the zero product property, which states that if a times b is equal to 0, then a equals 0 or b equals 0. Essentially what this is saying is if you multiply things together and the product is 0, one of the things, at least one of those things, needs to be equal to 0, because that's the only way to get 0 when you're multiplying numbers together. So just a quick example as to how we're going to apply this. If x minus 2, that quantity, multiplied by x plus 1 quantity, is equal to 0, then we want to figure out when these individual factors are equal to 0. And so the way we do that is we set each of those factors equal to 0 and then solve them. Adding 2 to both sides of the equation, subtracting 1 from both sides of the equation. We want to remember that when we're factoring, if there are two terms, we want to be worried about a difference of squares, or considering a difference of squares. A squared minus b squared equals a plus b quantity, a minus b quantity. If we have four terms, we want to consider factoring by grouping, and we always want to look for a greatest common factor. One additional reminder from a previous skill from this year is solving equations that involve square roots and also that potentially involve I. So if we were to solve this equation right here, x squared plus 5 equals 0, we would start off by subtracting 5 from both sides, which is going to give us x squared equals negative 5. When we're solving, we're trying to get the x by itself, so currently we have x squared, and so in order to make this simply an x, what we're going to need to do is take the square root of both sides. That's going to give us x equals positive or negative, which we need to include when taking the square root of both sides of the equation, and then we would have the square root of negative 5. But if you'll recall, we are going to factor negative 5 as negative 1 times 5 because the square root of negative 1 is equal to I. And so what we would get is x equals plus or minus I radical 5, or square root 5. So this is going to come up towards the end of the lesson, but I wanted to remind you of this now to activate that prior knowledge. All right, well, let's get going here. We're being asked to solve this equation right here. The first thing we're looking for is a greatest common factor. We can see that all three of these numbers have a common factor of 4. And so the first thing we are going to do is factor out the 4. We can see that we have 3 terms, and so we are interested in a product of 2 and a sum of 3. And what that would give us is x plus 2 and x plus 1, because 2 times 1 is 3, and 2 times 1 is 2, and 2 plus 1 is 3. At this stage, we are now going to examine the factors that contain variables, set them equal to 0, and solve them. When you have a numerical factor like this, you can ignore it in the process of solving because it doesn't contain any variables, and so we wouldn't need that. And so the solution to this equation would be x equals negative 2 and x equals negative 1. Moving on, we have this equation to solve. Because that is negative, right? We want to remember that that tells us that we need to consider factor pairs where one is positive and one is negative. And in this particular example, what that means is that we're going to have x minus 5 and x plus 4, because negative 5 multiplied by 4 is negative 20, and negative 5 plus 4 is equal to negative 1. Now that we have it factored, we are going to look at each factor separately, setting them equal to 0, and then performing basic algebra to solve those two equations. So we're going to do a few more trinomials that have some slightly different aspects going on, but we're not going to get to that right quite yet. Once again, greatest common factor. Here we have a greatest common factor of 5. So when we examine this trinomial here, we have a positive product and a negative sum. What that tells us is that we need two negative factors, because a negative times a negative is positive, and a negative plus a negative is equal to a negative number. And so for us on this one, we're going to have negative 1 multiplied by negative 1 equals positive 1, and negative 1 plus negative 1 is equal to negative 2. When this happens, when you get a doubling of one factor, we can express that as x minus 1 quantity squared. And what that means is we only have one factor, oh boy, to examine. All right, we don't have to do that twice. I apologize, that got a little cramped in there. All right, and so our solution to this one is just going to be x equals 1. Okay. In this next equation, we have a negative product and a positive sum. So we know that we need to deal with a positive number and a negative number. 7 multiplied by negative 2 is equal to negative 14. And 7 plus negative 2 is equal to 5. We're going to separate the individual factors, perform a little bit of algebra, and get our two solutions, m equals negative 7 and m equals 2. On this next one here, on number 5, we've got a little bit more going on than in the previous problem. So the first thing we want to observe is that we have an x to the 4th and an x squared. So we just need to be careful in terms of how we factor those. And aside from that, we're just looking for two numbers whose product is 12 and sum is 7. So 3 and 4 are the numbers that are going to satisfy those conditions. But because we have that x to the 4th and x squared, we're going to have to express this as x squared plus 4 and x squared plus 3. Now, this problem is going to have us use that little reminder about taking the square root of both sides of an equation to solve an equation. So here we have x squared plus 4 equals 0 and x squared plus 3 equals 0. So to solve this, the first thing we're going to need to do is subtract 4 from both sides. When I do that, I get x squared equals negative 4. So I'm going to take the square root of both sides. Upon doing that, we have to include the plus or the minus. The square root of this negative, right, is going to come out as I, but also the square root of 4 is 2. So we are going to express this as x equals plus or minus 2i. Once again, the square root of 4 is 2, and the square root of that negative, or negative 1, is I. So we'll solve the other equation similarly. Start off by subtracting 3 from both sides, which gives us x squared equals negative 3. We're now going to take the square root of both sides of the equation, leaving us with x equals, don't forget the plus or minus. Here, 3 is not a perfect square, so that's going to stay as the square root of 3, and the square root of this negative, or this negative 1, is I, and then we're left with the radical 3. Moving on, I think this is the last one we'll do, and then I'll record a second video with the remaining problems. This is taking a little longer than I had anticipated. So just like the previous problem, we have an x to the fourth and an x squared. So we need to remember that when factoring. Also, we have a positive product and a negative sum. That tells us we are dealing with two negative factors. Negative 16 multiplied by negative 2 is equal to positive 32, and negative 16 plus negative 2 is equal to negative 18. That is going to give us x squared minus 16 equals 0, and x squared minus 2 is equal to 0. We'll solve each of these separately. We're going to add 16 to both sides. We're going to take the square root of both sides. And we're not taking the square root of any negative numbers, so all we have to worry about remembering is including the plus or the minus. The square root of 16, of course, is equal to 4. Over here, we're going to add 2 to both sides. Take the square root of both sides, which is going to give us x equals plus or minus the square root of 2. All right, I think that's gonna do it for this video, and we'll post a video with the remaining practice review problems. Thank you, everybody. Talk to you soon.